Hey everyone, hi, I'm Abhas. So I want to talk about React hooks and why hooks is not just about functions. So when you talk to anyone, right, and you ask them like, what is hooks about? Like, what is React hooks or what did you like about it? The common answer is that, hey, hooks is all about functions. Functions are great. That's the future. It's good for people, good for machines, and all of that, right? And maybe someone will talk a little bit about composition. So you can write some reusable logic which you can import in other components and use, right? So the reusable logic, and that's good. I think yeah, both function and reusable logic makes sense. But I think that hooks also made some of the other smaller features better. It gave us some small improvements compared to what we had in classes. So I kind of want to talk about the other things, what other ways did hooks help us, right? What was a little bit hard, a little bit frustrating with classes, and which is like slightly better with hooks. Okay, so we'll start with state slices. So everyone probably understands what a state slice is, right? So if you have written in a class component, you would write in a constructor something like this dot state equal to, and then you put like your state slices in there. So maybe if your class component is doing two things, right? Let's say it has two features. It is controlling a model and it is handling some kind of a form input, right? So then your state will contain two things like show model and maybe some selected value, right? So these are what we call or think of as state slices. Now, in class components, you have to create your whole state at a time and say what all slices are within it. But with hooks, you can create your states separately. So let's say now I have three features in my component. Let's say again like model handling and form handling. Now my model handling code can do use state and create whatever state is required for its own functionalities, right? So it doesn't need to go to a common place like a constructor and add its own slice. Instead, it can create its own slice and update it whenever necessary. But with class components, all of the functionalities are kind of coupled at this point. So whenever you're creating your state, all the functionalities have to somehow come together and say that, hey, this is what my slice is going to be called, and this is what I want the initial value to be, right? So your functionalities basically cannot create the state separately in a class component. And the same thing kind of goes for updating your states. So whenever a functionality in a hook creates its own state using useState, let's say you do something like show model comma set show model equal to useState, right? So now whenever you want to update your show model, you can just call that set show model with true or false, right? So you can update it separately. But if you want to update your state with class components, you have to use set state. Now the thing of set state is that maybe you want to only update your part of the slice, but it's very much possible that due to some bug, you end up changing the slice, which is responsible for some other feature. So that set state is kind of global, right? Even though it merges your updates, you might end up changing the state for another functionality. And the other part is something like this. Okay, so the code itself is not very important. What I'm trying to show is that even though our set states are kind of atomic, I can say that set state with only show model, and it will merge with other states, right? I don't have to pass the whole state every time. But I think in class components, because they tend to think of the whole state as one big object, right? What we end up doing is something like this. So let's say this is a component will receive props, right? And here we're trying to check if the props changed in a certain way and then update the state accordingly. So let's say these two if conditions represent two functionalities, right? So this if condition is checking, if the props for a particular functionality has changed, then it wants to update the state for its own thing, and same thing for functionality 2, right? Now ideally what should happen is that these functionalities should do their own small set states. So maybe this thing should do its only do its own set state, which should update just show x, right? But instead what we end up doing a lot of times It's because we have that mental model of state as a big object. What we end up doing is that we create a whole new state, right, where we take maybe some of the old values. Then for each of the features, we modify this new temporary state. So it will modify the temporary state depending on the feature, and then we do one big set state. So effectively what we have done is that instead of keeping our functionalities separate, instead of updating their own things, they are merging to some kind of a common thing and doing a whole big set state. So your functionalities kind of tend to get coupled because they can't easily create and manage their own states. And I think an extension of that is also state isolation. So think of it in this way, right? Because hooks are reusable, you are probably going to use some reusable hooks, from some third-party library, right? So there should be a guarantee now that the hooks that you are using, they're not, their states are not going to collide with the states in your component. For example, if your state, if your component has some state, right, they should be isolated from the states in the hooks. There should not be any chance where your component might end up modifying the hook state by mistake or vice versa, right? So I think partial states and isolated states are kind of important to have these kind of reusable logics. So hooks is not just about function, state slices are also kind of important. The next small thing I want to talk about is derived variables, right? So like, what is a derived variable? Let's say something like this, okay? I have a props which contains data, so props.data, maybe that's like an array. And then I have some of my own data, so state.own data. And I want to merge them together into one variable, let's say merge data, okay? So maybe for some reason, I want to work on an array, which is like a summation of something from the props and something from my own state, right? And then I want to use this merge data for everything else within my component. So, initially it's very easy. So let's say you need merge data for rendering. So within render, you just create a new merge data, which takes everything from props.data and then puts your own data into that same array, right? So you are basically creating that new array whenever you require it. And that's fine. You can use this in render if you want to, render all these elements, and that is going to work fine, right? But what if you need this merge data? What if you need this derived variable in other parts of your component? So let's say your component also going to have other methods, right? So your component has some other methods. It has some callbacks, right? It has some lifecycle methods. So you want to use the same merge data in other parts of your code, right? So one way is, of course, you copy this thing and paste it in all the methods. But that's not exactly a good idea, because now you're going to have a copy of the same array everywhere. And also, what if this merging logic changes later on? So what if you want to put your own data as the first element maybe later, right? So ideally, okay, let's say if you want to share this merged data among multiple methods, what you can do is, of course, you can put it as a separate utility method, right? Get merged data. So now whichever method wants to use the merge data, they can basically call get merge data and use it, right? So this solves our availability problem. Now, whenever you need a derived variable, you can call this, and all your whole component now has access to your merge data. But there is still one small problem here, right? So whenever you call get merge data, you are creating a new array. So if there are 3 calls to get merge data, you are creating 3 arrays. So it's kind of a problem. So it's like a bit of an optimization problem, as well as this can cause a problem during checking. So let's say if you want to check the merged data between 2 renders. So if you want to see if merged data has changed between step 1 and step 2, then you can't really compare them directly because it's creating a new array every time, right? So you want some way of memoizing it. You want some way of getting back the same merged data if your constituents have not changed, right? So right? So some so that this merged data gets memoized, right? Now there is no inbuilt construct for this in our class component, right? So what do? We're going to make sure that merged data updates only when my props or state has changed. Now, okay, maybe I can put this whole thing in component will update, right? In component update, we get access to the next props and next state, and there we can check, okay, if anything has changed between my props and state, then only create this new value for this merged data, which is the new array, right? So we are effectively doing some kind of memoization ourselves by checking if props or state has changed. Right? So now we have kind of solved the availability problem because this is available on this.merged data. You can access it anywhere. And also we have solved the memoization problem where now if your constituents don't change, then merged data is also not going to be changed. So you'll get the same array back every time, right? But if you think of it, it was just too much work. I wanted to just have a memoized derived variable. So I wanted some variable which comes from two other things, right? And I wanted to memorize so that it's not changing every time. But there is no easy construct to do this in class component, right? So what I had to do is to go through all these hoops and see whichever I can, whichever case fulfills my requirement and just do that, right? So of course, I mean, even other than all these ways, the official recommendation from React is to use something like a memoization library, right? So they suggest to use something like a memoize1, which gives you a derived variable from these two things. But then again, that's a third-party library. So if you are using it at work, so that's another big discussion around whether you want to introduce a new library or not. So effectively, all I'm trying to show is that with class components, having memoized variables is quite a lot of work, right? Having derived variables. But when you move to hooks, this is a very easy thing to do. So what you do is something like this, right? So earlier we are having this method which gives us a new array. Now what you do is you pass that function to use memo and say that these are my dependencies. So if my dependency changes, then call this function to give me a new merged data. And also because this is a function, so if you create this merged data near the top of your function, it's also available everywhere. You don't need to put this into something like this, right? So it's kind of gives us an easy way of having memoized variable in case of hooks. Now, okay, so maybe we don't need derived variables a lot, right? But we'll see why that kind of matters in this section. So now I want to talk about the nastiest part of our component, right? So whenever I look at my class components, and there is this update life cycles which I just don't want to touch, right? So when I look at my component will receive props, that's like 80-90 lines long, right? So I mean, I have all these props check. So I'll check, start with something like this. So I'll do if next props dot foo not equal to this props dot foo, and then write some code, right? And very quickly, it turns into just a lot of code, which is very hard to understand, which is very hard to understand, why exactly we have written all this kind of code. So for example, this line of code within few days, right, turns into something like this. It turns into like this huge block of code where we are checking, okay, that if any of these variables change, then do this, or else if something else changed, then do something like this. So what I would like to do is, if anyone can unmute your mic and say that, okay, what is like a potential bug in this code, right? So is there any problem that you can easily see in this code? Like, can someone point it out?
Bars equals bars.
Yeah, so right, we are doing double equals, right, instead of not equals. So again, when I look at a block of code like this, it's very hard to kind of see these problems intuitively, right?
Can we use the switch case?
Yeah.
Can we use the any switch case? Because not to use the Yes, no.
Yeah, but how to use switch case here? I'm not sure,
Well,
because you have to check if foo of next props not equal to this dot props dot foo, right? How do I
okay.
use? I'm not sure how to use switch case here.
But there have any observer pattern means if any object value is changed, any observe anything will means any observing pattern is there. Any object value is changed, that object observer will come this type.
Yeah, maybe, but like that is not inbuilt to React, right? I mean, React directly doesn't give us that.
Okay, sorry.
Yeah. Also, can you like can someone else point out some other problem? Let's say, okay, this part of our code is already fine. Can someone point out a problem with this if else kind of a pattern that you have
Condition
written
keep
here?
changing. We can keep adding more variables. Then we need to add it, keep modifying this code.
We need to keep modifying this code. Like for example,
Like if we add some conditions, some more variables or some more
yeah, so
condition.
we'll have to keep doing else if, right?
Yes, yes, yes.
Yeah, so that is one thing, correct. So this is like hard to maintain, and
Hard to maintain our testing.
yeah, testing, right? Anything else which is can be like an actual bug in this code because of this else if thing. So we are basically saying that if any of these variables change, then do something, or else if this variable has changed, then do something else. Can something go wrong here, depending on how your parent is doing stuff?
Yes, it might be that both of them changes. The
Yeah,
if condition, if
correct,
food
exactly.
XYZ also changes. What goes first?
Yeah, exactly what you said is right. So as a child you might be thinking that either one of these will change or this thing will change, but you don't really know how parent is doing your change, right? For the parent, due to some implementation detail, both of them can end up changing at the same time, right? Then your else if code is not going to run. And even if you think that logically both of them are not going to change at the same time, let's say even if you're controlling your parent, you still can't be sure, because React can decide to merge two updates in the parent, right? React can decide that, okay, if the parent is doing two set states, instead of having two updates, you effectively have one update. So depending on how your parent is doing the props change, this might also cause some kind of a problem. So basically what I'm trying to show is that this looks like a normal piece of code. It doesn't look obviously wrong here, but it can cause some issues in some cases, right? So it feels like if I'm writing so much code and it can still cause some bugs, right? Why there should be some kind of an inbuilt way from React, right? So that I can do this props check in a easier way, right? And then there is a third example, right? So let's say till now we are comparing each variable in our props separately. So you're checking if like props.foo change and props.bar change. But let's say if you want to check if props.foo plus bar has changed, so if the sum of two props variable has changed, then you want to run some code, right? Now, I already have this kind of a method in my component, get foo plus bar, which does like this dot props dot foo plus this dot props dot bar. So these I'm, let's say, using in other parts of my component. So this already works, right? Now I just want to use it in component will receive props. But as you can see, right, I can't do it. I mean, I have to somehow run this get foo plus bar with next props or previous props to check if things have changed. So suddenly now I have to go to my other utility methods in the component and change their definition to allow some custom set of props, right? This is, really, it's kind of feeling weird already. The utility method that already worked for me, right? I have to go back and change them just so that I can use them for checking my props, right? Why should, checking our props be so hard, right? So that's why the Hook's way of using dependency array in user effect makes much more sense, right? So instead of us taking the previous prop and next props and comparing them manually, we just say that these are my dependencies. If the value of any of these things have changed, then run this effect. So for example, right, if you have even 4 or 5 properties that you want to check, you can just put them in this array. You don't have to write that repetitive kind of not equals equals every time. And same goes for our utility method. So if you have something like get foo plus bar, you can just call it here, right? Because your get foo plus bar only has to give the result for the current iteration, current round. And the React will internally check if it checks changes between two rounds, right? So it's going to do a similar, equals check. And if those two things are different, then only run this effect, right? But now, of course, you might say that, well, when I'm doing my check myself, right, I have more power, I have more flexibility, I can do more things, right? And one of the common things that I have seen in my code where I'm not doing direct not equals equals, right, is when I have a props which is changing every time. Okay, so like if you look at this code, let's say this is within the child where we are comparing props to a data array with previous and next props, right? So this can sometimes be problematic. So let's say if my parent has created a child like this, then my parent has passed this data array using this array literal, right? Then my props is going to change in every render. So this check is always going to give me false, right? Now, if you think of it, right, for the parent, it's doing, it's sending me a new array every time because it's just easy to do it, right? It can create a new array very easily and send it to the child. But for the child, now it's very hard to check if the array elements have actually changed or not. So it has to, either go through manually with all the elements, or it has to do something more expensive like JSON stringify. But the point is, this is also going to be hard if you use something like use effect, right? Because now you have to put your custom logic to check if your props have actually changed or not. So now if you actually look back, right, and if you look at this pattern where data array is changing every time, data array is giving you a new array every time from your parent, you can kind of understand why it is doing that, right? For the parent, this is the easier thing to do. In class component, if it has to cache this array, that's going to be very hard, right? And for the child, if it gets a new array every time, it's very hard to do that check. So what I think of it is like an incentive mismatch, right? So for the parent, it's easier to do one thing, which is to send a new array every time, but that is hard for the child. But if the parent does a little bit, if the parent writes a little bit more code, it can make sure that it is always passing in the same array. So the parent has to do more work, and now the child can do less work and get away with it, right? So this is the same problem as what we looked at during memoization. In case of class components, creating this new, caching this new array is very hard. But if you're using React hooks, right, you can use, you can pass this array to use memo and then send that memoized array from the parent so that this check becomes much more easier, and you can just use effect as normal. You can pass this array as one of the elements in use effect, right? So this I felt was one of the cases where we used custom checking with previous props and next props. But because you can memorize values now easily, so it's easier, you can just use effect and send memoized array from the parent. Now this of course has to be nested, right? So if your parent's parent is now sending a props which is changing every time, so it can cause like a cascading effect. So you have to make sure that from all the parents, it's always sending a cached value if things have not really changed. So the next part is that hooks makes like our life cycle much easier. So with class component, you have to write a similar code in all the life cycle methods. So if you do like a API call in did mount, you have to again do a similar call in did update, right? So if any of your props have changed, then you might need to refetch your own data. And similarly, it goes for unmounting also, right? So I have ended up with a lot of cases in my code where I don't do proper cleanup. So what happens is, let's say you do kind of a, let's say you do a API call in did mount, right? But because it's not so easy to do in class components, you don't store a reference to some kind of a cancellation token right? So ideally you should store some kind of a cancel method, and during unmount you should cancel all your API calls. Or if you are creating some kind of a timer, you should store your timer ID and clean that in your unmount. But I think we hardly do that, right? Same thing happens between your two updates. So if in one update you are making an API call, right, and then in the second update you are going to make a new API call for the same thing, you should clear your previous API call before doing the next one. But I think most of us hardly do that. The main reason is that it's hard to do that, right? If you create a API call in did mount, now you have to store a reference to that somehow in this dot something, right? And then later on in unmount you have to use that this dot something and call it. And these are also two separate methods in different part of your code, right? So you tend to sort of forget to do these things, right? Because it feels like just so much work. You have to remember what you are creating in did mount, store it somewhere, and in again unmount you have to remember to clear all this stuff. And also, as you said, not just unmount, even between your two update cycles you need to clear whatever is the effect that you created in the previous cycle, like previous update. So that's where I think the Mars lifecycle hooks or something like use effect or use layout effect makes these things much more simpler for hooks, because your same code will run for most of these things, right? So whatever you want to run in did mount and did update, you can write in the same place. And similarly, if you want to do the cleanup, it's also in the same place. So whenever you create an effect, you just specify the cleanup code just after that, right? So they are just co-located one by one. So it's easier, and it's easier to remember to clean up the things that you are doing during a effect. Now we all know how like use effect works, right? So I'm not going to go through like what are the parts of use effect, but what I think is sometimes helpful is this kind of a mental model. Okay, so what I'm trying to show here is that this green thing is like, let's say, your effect, and the red thing is your cleanup. So by default, if let's say your dependency array is empty in use effect, right, you are going to run your effect on mount, and the cleanup of this effect is going to run on unmount. So mount is always like your default effect, right? So mount is always going to run your effect, and unmount is always going to clean up your effect if you have like some cleanup code, right? And now what happens when I introduce a update in between, right? So you can see that there is this in this mental model, you can see already kind of this zigzag pattern appearing, right? So let's say now we have a new update, right? Okay, so let's say now when we have a new update, what it really means is that whichever effect code you run in mount, right, it gets cleaned before the next update. So let's say if this is round one and this is round two, then the cleanup code for round one always runs before round two. So if that was the effect, this was the cleanup happening right here. So whenever you add more updates, you basically add this kind of a pattern. And similarly, whenever you create some effect in update one, that will get now cleaned up in unmount, right? So whenever you run the next effect, the cleanup of the previous effect runs just before that. And we can extend sort of this same kind of thinking to other things. So let's say now your mount let's say your component is going through multiple updates, right? So this is like when it's causing first update, this is like when it's causing second update, right? Now when you put a few more elements in our dependency array, so let's say if we say that this update is because of props 1 changing, and this update is because of props 2 changing. And now let's say in our dependency array we say that use effect and run it only when props 2 changes. So what we are basically saying is that among all these updates, filter it down to just this update, right? So only take this peak, uh, don't care about all the things happening in between, right? And then you are basically using your dependency array, you are filtering down this sort of zigzag pattern to the part that you want. And similarly, your cleanup always happens just before your next effect. So yeah. So the other thing I kind of think is that, one of the differences, this is not really a practical difference maybe, but as a theoretical thing, right? Uh, so we always have some features, every component has some features, right? It's going to do X, Y, Z, three things. And each feature is going to need a few life cycles. So each feature is going to probably need some state, is going to probably need to do something during update, and maybe during to do something during cleanup, right? So it's kind of a X into Y kind of a problem. You have X features which all need Y life cycles, right? So I think in case of React classes, what it did was it grouped by life cycle. So in React components, whenever we write something like component did mount, what you're basically saying is that, you know, uh, for all the features, right, for all the things that you want to do, what all is going to run during mounting, right, or after mounting. But in case of hooks, what we tend to do is group by feature. So we tend to say that, okay, I don't care about what all is going to happen during update. What I care about is for this feature, what are the life cycles that we need, and can we write them together, right? Can you write the whole code in the same place? So I think this makes kind of, more sense for how we think. So we humans kind of, you know tend to think of, things as features. So we need to look at, okay, what all is happening during this feature, instead of thinking of what all is happening during this life cycle. So this is probably closer to what the library will want to know. So React will probably want to know that what all do I need to rerun, or what all code do I need to execute when the mount is happening. So I think this is one of like the, like the mental model where you say that, in classes it used to be sort of grouped by life cycle, but now it's more like grouped by feature. At least it allows you to do something like this. And the last thing is that, so even though a lot of things are like good about function components and hooks, right? One of the problems I have faced from time to time is organizing, the parts within a function component. So I understand that, we are supposed to refactor our function, right, into small hooks so that we can reuse it and make the function smaller. But there still tends to be, a few sections within our function component which it's more like a scaffolding code, right? So you always start your function with function component with, initializing. So you extract some props out of what you have got. Maybe you process your props a little bit to get whatever exact value you need. Then you initialize some of your own state. You initialize whatever custom hooks you need, right? So you do a lot of initialization code at the beginning, and then you think about, okay, what all updates am I going to handle? So, what all use effects do I need to respond to, right? And then again, you are going to write about what all utility methods do I need here, right? So, overall, what I'm trying to say is that we end up with a lot of scaffolding code in our function component, and I don't see a good way of grouping them together. So there is quite a bit of initialization code. There is quite a bit of, where you create some methods, like you create use effects. You say, what all callbacks do I need, and what all utility methods do I need. And then finally in render, maybe you create some partial renders. So you say that, okay, this is how I want to render my head, this is how I want to render my body, and then put them all together in, the final return statement. So I feel like, this is sometimes a little bit hard to organize, especially if you don't kind of demarcate your code into separate sections. So yeah, I would like to, really get your thoughts on if you know of like a better way of organizing function components. So this is one of the problems I have faced while using it. So yeah, that's all from my side. And you can see more on this website, I guess.
Yeah, so I think we have 5 minutes for questions.
Okay.
Like if anyone has questions, you can maybe unmute and ask questions.
Thank you, Abhas. That was an excellent talk. So basically, my question is more of what happens if we try and create more functions. So when you say that how to organize our functional component. What
Right.
if we end up creating more smaller functions which handle, let's say there is an initialization functions which is given, and it's a pure function which given the right input gives us initializes all the, like, let's say the first steps within all the initial hooks that we need, and it does that outside of this. Is that is a possibility?
Okay, yeah. So you're suggesting that okay, we make another maybe like a hook which
Yeah.
returns all these values.
Hmm.
Yeah, yeah, I
That
get.
might lead to overcrowding in some sense, because I think this way at least the code is easier to read for a developer who might be in a hurry and you're just solving this. As long as, like, the codes are demarcated the way that you have, which most often than not it kind of loses its space and we end up not doing so,
Right.
like especially with, like, and we obviously don't tend to like write that here we are like initializing like the exact thing what we are doing, as opposed to it's more along the lines of what this code does, like what the following function does or what the following thing intends to do.
Mm-hmm.
So the demarcation becomes even more blurry, because we won't write that here I'm initializing hooks. You might just write this hook is used for, let's say, mapping
Yeah.
the cursor movements from here to here,
Right.
and that way then you end up losing track of exactly which hook is derived from where. Is it a custom hook? Is it a
Yeah.
hook that has been created within it? So yeah.
So yeah, I mean, what you said makes sense that we can technically put it into a different function, but then that
Yeah.
function wouldn't really have much of a sense, right? We are
Yeah.
basically making a random function which exports all of these things. So yeah.
Yep. Do you feel like there are, like, right now, if you were to hop on a new project, so this is my like final question, is that would you still consider a class component as a useful entity to use in that? Is there a use case now that kind of presents itself or in these certain scenarios, I'd still prefer using a class component over a functional component?
Mm-hmm. So I think, yeah, I guess in general, I would prefer using function components because they have most of the features. And like I was kind of trying to say that some of the things are easier to do. But I think there is only probably one use case about like component did error, which you currently cannot do with function components. But I think we still use it in very particular top level components. So I guess most of the cases I would still go for functional components.